The last thing that we're going to do today is a real world problem. We'll call this problem number 12, and you should take your glue in and put it right here. This is going to talk about sound. And for a sound with an intensity I in watts per square meter, the loudness L, which is a function of I, so L of I, of the sound in decibels is given by the function L of I is equal to 10 log of I divided by I naught, where I naught is the intensity of a barely audible sound, about 10 to the negative 12th watts per square meter. All of that to say that we want to determine when an artist in a recording studio turns up the volume of a track so that the intensity of the sound doubles, we want to know how many decibels that the loudness increased. So we are starting with some intensity. We are ending with an intensity that's 2 times that, and we want to figure out what the L value is at double the intensity. So let's just kind of write ourselves a basic formula first. So our basic formula is going to be that the loudness that we end with, loudness at 2 times the intensity, and then we're going to subtract the loudness that we started with, the loudness of our regular intensity, the starting intensity, and that's going to be the equation that we need to solve. So we know that loudness evaluated at 2I, I'm basically going to replace I everywhere that I see it, just the plain I, not the I naught, with the 2I. So let's go ahead and do that, and that will give me 10 times log of 2I over I naught. And then I want to subtract my original intensity, which is 10 log of I over I naught. Okay, I have a 10 in both of these locations. Let's just pull that out as kind of a greatest common factor. So let's do our next line as 10 multiplied by log of 2I over I naught minus log of I over I naught. And that's just pulling out a GCF, kind of like we do when we factor. Okay, I see that I have a multiplication going on here because I have 2 multiplied by the I over I naught. So I can break this apart as a log of 2 and a log of I over I naught. And so in order to break that apart, I am using my product property. And let's look at what that's going to be. So this is still going to be 10. And now I'm multiplying by log of 2 plus log of I over I naught. So I've just pulled this 2 out because it was being multiplied. I'm leaving the division for a minute, and I'm going to show you why. The rest of my expression is log of I over I naught, and it's being subtracted. So notice what has happened here now. I have a positive log of I over I naught. I have a negative log of I over I naught. Those are complete and total opposites. And so those are going to cancel. And this is just going to leave me with a log of 2 on the inside. So I have 10 multiplied by log of 2. And that's just a simplify step. Those canceled. Finally, I can put 10 multiplied by log 2. We are in common log form. Log base 10 is implied. Just put that into your calculator directly. 10 times log 2. And this is going to be about equal to 3.01. And remember that the Loudness was in decibels, so we can say decibels, which is a lowercase d and a capital B, decibels.